I have a screencast among the several for chapter, for module 3, chapters 7 and 10, 11. Had to think about that. And I may even have a written out example, but I thought since I didn't get to my example for last night's class, and this is one of the very few concepts in chapter 7 that I do want you to know, I thought I'd put up another numerical example. So here we go. So this is the one I had prepared for you, and you'll see I have the answer up and two ways to get to that answer. Let me just show you one of those ways. Though I have in the slides from last night's class, I have a picture of the spreadsheet I used, which is the brute force way to do it, and it's somewhat easy, but it's not that hard to do by hand either. All right, so here I have a problem. So I have this game that I imagined. I could pay 75 cents, or you could, and then somebody rolls a fair die, 6-sided die, and fair just means every side has a 1/6 chance of turning up. And then what's going to happen is if a 1 turns up, you get 1/4, a 2 turns up, you get 2/4, etc. And then what is the expected value of your winnings? So this boils down to the expected winnings. Oh, shoot. Winnings with 2 n's minus $0.75. Actually, I think I'm going to do it in cents. Let's just do it in cents. Minus 75 cents. So this is the expected winnings are the key thing that we need to solve for. And that green is sort of bugging me. I think it's green. I'm a little bit colorblind, but let's calculate the winnings there. So it's 1/6 times 25 cents. That's if a 1 comes up, plus 1/6 times 50, not 55. Plus, I mean, you get the idea, right? 1/6 times 75, that would be 3/4, plus 1/6 times $1, plus 1/6 times 125, plus 1/6 times 150. Can I squeeze it in? Yeah, that's a 0, not a 6. Darn it! I had it if I had just not gotten so sloppy. And then that's a lot of numbers to plunk into your calculator, but it's not that hard. 25 divided by 6 plus 50 divided by 6 plus, so it's not that hard. But notice one way to make this problem easier is that we can factor out 25 over 6. Every one of these expressions has 25 over 6. This is 25 over 6 times 1, 25 over 6 times 2, 25 over 6 times 3, etc. So we end up with 25 over 6 times 1 plus 2 plus 3 plus 4 plus 5 plus 6, which equals 25 times 21 over 6. And we could factor that a bit. Wouldn't be that hard, but let's just pause it. I'll go to my trusty rusty calculator. And this is of course all the expected winnings. And that turns out to be 87.5 cents. So 87.5 minus 75 cents, these are both cents, is 12.5 cents. And so D is our answer. And that's how you do it. And you could flip a coin. A fair coin would be 1/2 times the first value plus 1/2 times the second value. There's a lot of ways to randomize. So anyway, there we are. I have sorry for that pause there. I have a follow-up question that's actually sort of interesting. Well, to me, I hope it is mildly interesting to you anyway. So here's the question. If you are risk averse, that means you need to be compensated for taking on some risk. You would not play the game described in the previous application exercise. So true or false? And remember, we just did it, but remember that the game was a better than fair gamble. A fair gamble means that your expected value is 0. A better than fair gamble means that the expected value is positive. A worse than fair is that it's negative. And so this is a better than fair gamble. If you were risk neutral, that is, all you care about is the size of expected earnings, and you don't mind having risk, you don't love it, you don't hate it, but you're neutral to it, well, then you definitely take that gamble. But would you take it if you're risk averse? And actually, we don't have enough information. C is the right amount. And the reason we don't know is that we know that the game has a positive 12.5 cent expected value. So on average, if you play it enough, you're going to come out ahead. But for you, given your risk aversion, is 12.5 cents enough to compensate you for taking on that risk? And that is idiosyncratic. Some people might be so risk averse that 12.5 cent return on 75 cents isn't enough. I don't know anybody that risk averse, but the point is, without knowing something more about the nature of someone's utility function, which would tell us how much someone would need to be compensated to take on any given risk, without that information, we just can't tell. So I just wanted to throw that in there. Again, risk aversion defined. I'm not going to hit you too hard on any of this, but not the risk aversion stuff anyway. Risk aversion is just having a dollar for sure is preferred by a risk-averse person to playing a game that has an expected value of $1. You'd rather have the sure dollar than the gamble that'll, on average over time, earn you $1 every time. That's risk aversion.